Well, even if they are, dependent, what we did is at the end of the day, we simply multiplied probabilities. So what is the probability of getting tails when you toss a coin? 1/2. What is the probability of getting a number greater than 2 when you roll a 6-sided die? 4 out of 6. If you simplify, the answer would be 1/3. So that's that probability of having the mutation, which is 1 in 600. The probability that person would have breast cancer, B, given the fact the person has the mutation, is 0.6 or 6 out of 10. So probability of A and B is 1 over 600 multiplied by 1 over 6 over 10, which is 1 over 1,000. Does that make sense? Even though we have a conditional probability here, in other words, dependence between the mutation in the gene and developing breast cancer, at the end of the day, when you're finding a joint probability, all you're doing is multiplying. Does that make sense? Okay, so probability and adult knowing a matter of a 10 is 300 out of 1,000. Now, that's for the first adults, but here we're saying that we're going to choose those 4 adults without replacement. So for the first adult, it is 300 over 1,000. Yes. Now, as we go along, since we pick 1 out, how many would we have next? Come again.
No.
299 over 1,000, or is it 299 over 999? Okay. So for the first adult, I'll call it A1. The probability would be 300 over 1,000. The second adult, it would be 299 over 999. The third adult, 298 over 998. The fourth adult, 297 over 400 and oops, 997. Realistically speaking, though, this is not good practice in a problem like this. If you do a survey, you're not going to assume that I'm going to pick one person out and then go for the next one. We will have a fixed amount in the sense we will make sure that they are independent. So we have the 4 probabilities. Does it matter which one I call A1, which one I call A2? No, it's just random adults. People the naming here doesn't matter. So all 4 adults know a murder victim. That would mean the first one does, and the second one does, and the third one does, and the fourth one does. So what should you do to the probabilities? Multiply all of them together. Running of respect. And 4 decimal places. And what is that answer?
0.0079.
0.0079. Is it correct? So it is always better if you draw something like this, especially if you cannot visualize it in your head. So of course, it's a clear partition. I could have drawn the box and split it in half, but I didn't do that because this is how it's done. So in total, we have 1,000. And think of it this way: you've got a box where you have 300 people, got another box where 700 people, they do not know a murder victim. And we are picking people from this group without replacement. So none of them knew they were a murder victim would simply mean the first one did not, the second did not, the third did not, and the fourth did not. So the probability that the first one did not know is 700 over 1,000. The second one would be 699 divided by 999. 698 divided by 998. 697 divided by 997. So what do we get? 0.2. So probability at least one of the 4 adults would mean there are 3 separate events, and any of them could happen. Or actually 4. So nose, doesn't, nose, doesn't, nose, doesn't. Right?
Yeah.
And we know the probability that a person is going to know a murder victim, and without replacement, I could keep on doing this. But too much work. Do you agree? You have to repeat this part, with the numbers 4 different times and add them all together. Yes. Too much work. But what is the complement of at least one of the 4?
0. None of them.
So at least one of the 4 know a murder victim simply would mean 1 minus the probability of none of them.
3 do not know. That means
Right?
Yeah.
Semantically speaking, this is the same as saying all 4 of them do not know a murder victim, right? So we already know the answer to that, right? The first one doesn't know, the second one doesn't know, the third one doesn't know, the fourth one doesn't know. So that probability is simply 0.2395. Now, great, we are able to come up with the number, but does it make sense then? I'm saying there's a 76% chance if I pick 4 people that at least one of them would know of a murder victim. Does that make sense, given this?
yes.
Yes? The reason being at least one, which would mean 1 or more. So there is a good probability that I'm going to encounter someone, I'm going to see out of those 4 adults that at least one of them knows a murder victim. Again, if you did not use the complementary rule, the complement of at least 1 is none. If you can't see that, can I raise the top part? You can't have half an adult. Yes, sir.
Can you show us how it would be if it was 1 of 4 and not at least 1 of 4, like how you would do that?
Exactly 1 of 4 knows.
Yeah.
Okay,
Because
next
you
one.
have to have like some feature.
Yeah, next one.
Oh, okay.
I'll do that one separately. So at least one of the four would simply mean 1 minus none. Easier way to remember, that would be 1 or more. Agreed?
Yes.
1 or more, at least one, same thing. What is the complement of that?
0.
Exactly 0. 0 means none. So if we call this to be event A, that would be the complement of event A. And we know how the event A is related to its complement. Probability of event A is equal to 1 minus the probability of its complement. Good. And we found the complement in the previous part. Going to erase this side.